Quick note, this video isn't flight training and it's not a flying recommendation. We're just looking at public info, radar playback and ATC audio, to help non-aviation folks understand what's happening in our airspace. Ever look up at a plane and think, is that basically in my backyard? Or is my depth perception just freelancing again? Today I'm trying to answer one simple question that turns out to be not simple at all. How high is that airplane really flying? In this video I'll walk you through how I tried to estimate aircraft altitude as accurately as I could, using some cheap measuring gear plus a few apps that are way cheaper than the measuring gear. Not hard. You'll see 8 flyovers with audio filmed from my Camera 9 spot in the Palomar Estates West Mobile Home Park on Friday, April 10, 2026, from 11:43 a.m. to 12:11 p.m. For production I kept it simple. One app, one camera, and one iPhone, because nothing says serious documentation like using the same device you use to order tacos. The camera is on a tripod, pointed at a 348 degrees heading with about a 30 degrees tilt, in portrait orientation, using a 35mm wide-angle setting. I tried using a high-voltage power pole under the flight path as a reference target. That plan lasted about 5 minutes, because wide-angle lens distortion is basically the funhouse mirror of video. I also thought about scaling the aircraft using its known length and backing into altitude, but, same problem. When the lens is bending reality, the math politely resigns. In post-production, I can build an overlay in a CAD program and tweak it to match a known altitude. But because I need a wide field of view to capture both the aircraft and the ground, and because the wide lens refuses to behave, this isn't reliable as a standalone measurement when the subject is far away. Next time, a closer setup with a longer focal length should give me less funhouse and more science. I also grabbed live screenshots on an iPhone using FlightRadar24. It gives you altitude readings, but they aren't corrected for local pressure differences, and there can be a little display latency depending on how the feed is processed. So it's great for time-stamped, this is what the app said at the time, documentation. Just don't treat it like a laser-measured truth machine. You can look up pressure settings and try to correct the values, but then those adjusted numbers don't always line up with later historical playback. And once you start comparing replays, the plot thickens. One source might show a slightly different altitude than another. An error of about plus or minus 50 feet isn't a huge deal if the aircraft is 500 plus feet above ground. But when planes get lower, that same meh difference becomes a wait, actually difference, and close enough turns into close-ish. Historical flight data also depends on where you pull it from. FlightRadar24 uses a mix of ADS-B and official FAA radar history. Raw ADS-B can be very accurate, but after processing you may see smoothing, gap filling and other make-it-look-nice adjustments. WebTrack is widely used for noise monitoring and it's the airport's official complaint site, but the altitude can look wildly off sometimes. It may be displaying altitude differently, potentially closer to above ground, which gets complicated fast when the terrain isn't flat. Another solid tool is ADS-B Exchange, which shows flight data in a pretty raw form. It has a low-latency live map and a playback mode for history. You can download KML for Google Earth, which is awesome for a 3D view, but it's not always the easiest way to capture clean, labeled altitude points. For documentation, the unsexy method often wins. Open playback on a desktop, isolate the aircraft, and take timestamp screenshots so you've got a permanent record. And then there's Get Noisy, a community-based noise monitoring system that adds another layer of flight plus sound data. Think of it as crowdsourced, yep, that one rattled my windows, with timestamps. Okay, time for the flyovers. For each clip I'll call out what it is, what the tracking data shows, and anything weird or interesting, including the stuff that made me go, ha. Clip 1. American Airlines Embraer E175. Nothing is wrong here. I just happened to catch this one and several others on approach into Palomar during my observation window. The standout detail is the loudness. E175s often come through a few dB louder than other jets. My working theory is that the short runway at Palomar might push a landing configuration that's a bit noisier, but the jury is still out, and the neighbors would like that verdict ASAP. Clip 2, Beechcraft King Air B-20. This prop plane diverted its course slightly to create more spacing behind the regional jet in front of it. Pilots do that to avoid wake turbulence. Because the flight path shifts farther away from the camera, the aircraft looks higher in the video. But the altitude can remain essentially the same. It's the increased distance that creates the optical illusion. Clip 3, United Embraer E175. This one is flying at a similar altitude to the American jet, suggesting they're on ILS or another form of instrument guidance. One interesting detail, United tends to fly the approach a bit slower than American in my sample, about 112 knots versus 120 knots for that earlier flight. Clip 4, Cirrus Vision SF50, aka the Vision Jet. It's a single-engine, very light personal jet built around simplicity and safety, with a compact design that makes it look like the efficient commuter of the jet world. Small jet, big idea. Clip 5, C56X Cessna Citation XLS Plus. A Cessna Citation 560XL is much smaller, roughly half the size, of an Embraer E175 in both physical dimensions and passenger capacity. They're in totally different categories. The C56X is a mid-size business jet, while the E175 is a regional airliner. And even with the smaller size, it can still put out some serious noise, proof that little doesn't always mean quiet. Clip 6, C700 Cessna Citation Longitude. Size-wise, it's closer to an E175 than the C56X is, maybe around 3/4 the footprint, but the E175 is still larger across the board. The surprising part, in this group, the C700 was one of the quietest jets I captured. Clip 7, C-25B Cessna Citation CJ3. One of the most popular light business jets out there. It sits in the sweet spot between efficiency, range, and cabin comfort. Basically the just right bowl of porridge if Goldilocks flew private.
It's not super high, and I said, it's really close, so I don't even know why we need to worry about it. And he told me that I need to get down to 50, not 100 on this big. I don't know. He's gonna spell it.
Yeah, cholesterol, our body needs that.
To live on, if we need it.
So we can live. Yeah. Without the cholesterol, and they give you medicine to lower it down, then that might...
Clip 8, GLF-4 Gulfstream IV. A large cabin long-range business jet that helped define an era of corporate aviation. Spacious cabin, serious range, and avionics that were a big deal in their time. When one of these goes by, it has a presence, even if you're only meeting it briefly from a mobile home park.
That's just the private jet. Looks pretty low to me, but I don't know.
To wrap it up, filming aircraft altitude is still worth chasing, but it's not a silver bullet, especially at long distances with a wide lens. App data and radar-based playback are super useful, but they're not perfect if you need truly precise numbers. So for now, my best casual documentation recipe is: combine sources, screenshot everything, and be honest about the uncertainty. If you want to see me refine the setup and hopefully get less funhouse mirror and more useful measurement, I'll do another airplane altitude video in the future. And if you've got better ideas, or you spot something I missed, drop it in the comments. Thanks for watching.